Going on now to Chapter 8, Section 1, Quadratic Equations. And we'll be doing the topics, the principle of square roots, completing the square, and some problem solving. To start us off, we'll take a look at some of this vocabulary and our matching 1 to 4. So as we see number 1, the equal signs, this is an equation, and since it's to the second degree, it is a quadratic equation. This, you recall from an earlier chapter, is the standard form of the quadratic equation. Up to now, we used to factor this to solve it. In this chapter, we're going to learn some new ways to do it. And in the process called completing the square, we take this first part of the quadratic expression where our b term, we're going to take half of that b term and then square it to do something, and we'll show you that here shortly too. And compounded interest is when we have an initial investment and then the next month or the period of time that it's due for interest, the interest is included in the amount we get the new interest on. So it tends to be a little bit more each compounded time. Okay, going on to this next part. What they're asking here is determined just by looking at the graph if this equation, which when we put it into our graph forms a parabola, how many real number solutions do you get? Well, when a graph like this crosses the x-axis, and remember we did some of this when we said finding the zeros, that is when y is 0, this is a 0 here, this solution would be the x-intercept of -7, 0, and this one is 5, 0, the x-intercept. And whenever the parabola crosses the x-axis, as it's doing here, then they are real number solutions, and there are 2. And these are them right there. Now as we look at this next one, and we graph it, notice there are no points of intersection to the x-axis. The parabola doesn't reach it. So this has no real solutions. Doesn't reach the x-axis. Now, whether you had the class or not, at this time we're going to introduce the principle of square roots. That is, we want to find out what t squared when it's just t is. So the first thing we're going to do is divide both sides by 6. This gives us t squared equals 3. And then what we do is we take the square root of this side. That'll give us t. And then in order to get both solutions, we say plus or minus the square root of this side. So t equals plus or minus the square root of 3. This is what we call the principle of square roots. Now over here, we're going to solve for the x squared. We had to divide both sides by 4. So when we transpose that, that came over as a negative 81 over 4. And again, we take the square root of this side. That will give us x. And then it's plus or minus the square root of this side. Well, now notice we have a negative under the radical, but now we have a tool to deal with that. That's going to be 9i over 2. So this, and it's plus or minus, this is an imaginary number, so this one has no real solutions. Now, in number 9, this is building us up to what we're going to do shortly. Here we have a binomial that's squared. So we're going to use the same principle. So we're going to take the square root of this side. That just gives us the radicand. We take plus or minus the square root of this side, which gives us plus or minus 10. Now we transpose the negative 3 to make it a positive 3. So we now have y equals 13 or negative 7. Those are our solutions. And the same thing here. So following what we've done, this is a parenthesis by the way, we take the square root of that side and then plus or minus the square root of 2. This then becomes x equals a negative 5. We transpose that plus or minus the square root of 2. And for this one, we take the square root of this side plus or minus the square root of that side. This gives us a. Now we transpose the 7. That becomes a negative 7. Plus or minus, now the square root of negative 4 is 2i. That's what we had from chapter 7 there. Okay, this one again, take the square root of that, plus or minus the square root of that. And notice the square root of 8 is the square root of 4 times the square root of 2. Square root of 4 is 2. So this is going to become plus or minus 2, the square root of 2. Square root of 9 is 3. And we bring that over as a negative 2/3. And there are our answers. So we see once we get something as a binomial that's squared, we can use this technique. Now as we do number 13, I don't know if you recognize, this is a perfect square trinomial that we're going to factor into x plus 6, the quantity squared, equals 7. That's function notation for this. So we're going to take the square root of that, plus or minus the square root of 7. This then becomes x, transpose the 6, negative 6, plus or minus the square root of 7. So if we had an equation, this equals 7, which is what we had, and if we factor this perfect square trinomial into a binomial square, then we have a very easy way to solve it. And here's just another example. There's a binomial squared that we're saying equals 25. So we're going to take the square root of that, plus or minus the square root of 25. This is going to give us t equals, now the 8 comes on this side as a positive 8, plus or minus 5. So t will equal 8 plus 5 is 13. 8 minus 5 is 3. When you have a perfect square under the radical sign, you can give your two answers this way. So what we're going to do now is do one of the steps that results in completing the square. Now, if this were a perfect square trinomial, then we could factor that into a binomial square, which is one of the techniques I like to use, and they put it here over on the side. So, how do we get that if we have this term and bx? Well, the rule is you take half of b, there's b, take half of it, divided by 2, and then square it. That's going to give you your c term. So we're going to take half of b, and by the way, we put that right down here. Half of b is that. Now we square this, and that's going to be 100. And this is just that. Again, my technique is we do it like so. The t goes there, the negative goes there. What's half of 12? 6. Square 6, 36. And again, this technique, put that there. Now, t goes there, the minus sign goes there. What's half of 5? Well, just divided by 2. That's half of 5. Now, square this. Well, that becomes 25 fourths. This one's a little tricky, but not too bad. Now, what's half of 4 sevenths? And just multiply it by 1/2. Here the 2 can cancel, and this becomes x plus 2 sevenths. Now, square that, and that becomes 4 49ths. And if we factor that, we get this, which is what we have to put over here. 4 49ths. Now, what are we doing here? Filling in this blank, we're doing a process called completing the square. We have made these now perfect square trinomials that will factor into their binomial squared. Now, suppose we have this quadratic equation in standard form, and they are saying solve by completing the square. What's the first thing you should do? Well, you write it. Then take your c term, that's your c term, and bring it to the other side somewhere. And that's what they gave us this. So I wanted to see where it came from. This is in standard form. The first thing you do is take your c term and bring it to the other side and watch the changing of signs. Then you're going to put a little parenthesis like so, and you're going to put your x there. This is a plus. Now, your b term is 1. What is half of 1? Or divide 1 by 2. Becomes 1/2. Now what we're going to do is take this 1/2 and square it. And that gives you 1/4. Now, if we had that, this is a perfect square trinomial that would factor to this. But, interestingly, we don't have an equation anymore. Why not? Now, if I had a class, I'd say this is for a bonus point. And the answer is because on this side, you didn't add what you're adding to that side. Now it's an equation. Okay, now I want to add these two together. So this is actually 80 over 4. 20 is 80 over 4. 4 in the 80 is 20. But I want to add them together. So I get 81 fourths now. Now I take the square root of this side and I go plus or minus the square root of that. X now is equal to, I transpose the 1/2. That becomes a negative 1/2. And this becomes plus or minus 9/2. And I now take a negative 1/2 and a negative 9/2 and get a negative 10/2, which becomes a negative 5. So that's one of my answers. I take the negative 1/2 and the positive 9/2, and that gives me a positive 8/2, which gives me a 4. And there's my other answer. Remember, we're dealing with equations to the second degree, so we need two answers. And we solved this one by completing the square. This was a rather hard example. We'll have some easy ones. Now, I could write these out ahead of time, but I want you to see the process. So the C term is already on that side. So I'm going to put my parentheses and my little square, and my negative 8 is over there. So T minus, what is half of B? Half of B is 3. If I square 3, I get a 9. So I have to put a 9 there, but I have to put a 9 there as well to keep it balanced. So this now, when I take the square root of this and plus or minus the square root of that, which is plus or minus 1, it becomes a 1. And I transpose my negative 3 over, it becomes a positive 3. So here, my answers are 3 plus 1 is 4. 3 minus 1 is 2. So that was sort of an easy one. Okay, this one's in standard form. First thing I do is, I'll write this one all out, t squared minus 4t. So I take my c term and I put it over here as a negative 2 when I transpose it. Now I put my parenthesis. I'm going to put the t there, the minus there. Now what's half of 4? 2. So what am I going to add to both sides? Well, I'm adding a 4 here when I square that, and I add a 4 there. So this now becomes a 2. So now I take the square root of that, plus or minus the square root of that. T equals, transpose my negative 2 to this side, becomes a positive 2, plus or minus the square root of 2. Those are my two answers. Doing this one, I'm going to use the parenthesis, transpose that 2 over as a positive 2. Half of that is going to be 3. Now remember, I'm going to add a 9 on this side and a 9 on that side to make that a perfect square trinomial that I factor into that. I'm sort of skipping that step now. Now I take the square root of this, plus or minus that. That's going to be plus or minus the square root of 11. This comes over as a negative 3. And there are my two answers for number 22. Now in these next, they're asking us to complete the square to find the x-intercepts of each of these functions. So it's sort of like finding the zeros. That is, where the parabola will cross the x-axis. The value for y here is 0. So we put that there. And let's just do it. So x squared Well, I don't have to write that again. I'm going to use this parenthesis squared. I'm going to transpose that over to this side, and that becomes a -9. That's an x. This is a plus. Half of 8 is 4. I'm going to add 16 to both sides. So this becomes 7. I take the square root of that, and I get x equals, transpose that 4 as a -4. And these are my two ordered pairs. A -4 plus this, a -4 minus this. And that would be these points there. Same thing here. This is a parabola. So, parenthesis for two terms. I'm going to transpose this over as a -2. Put an x there. This is my b term. Half of my b term is 2. So I'm going to add 4 to this side and 4 to that side. So this becomes a 4. Take the square root of that, plus or minus the square root of that, which is plus or minus the square root of 2. Bring my 2 over. This -2 comes over as a +2. So 2 plus the square root of 2 is 1. 2 minus the square root of 2 is the other. Now, I didn't draw these accurately. They're just to show you these are the x-intercepts. Remember, x-intercepts are given as -4, let's say minus the square root of 7, and then a comma, 0. Okay.